What's up, everybody? Welcome back. Moving on to another question. We have a polynomial equation here. So we got 5x cubed plus 3x to the power 4 minus 13x squared plus 7x equals negative 6x plus 3x to the power 3 plus 3x to the power 4 minus 28. And we have to solve for the x values that would make this equation hold. So if you remember with polynomial equations, what you want to do is you want to bring everything over to one side, right? So let's take these four terms here on the right side and then bring them over to the left. So we'll write out everything here again on the left side. And then bringing everything over, this negative 6x turns into a positive 6x. This becomes negative 3x cubed, negative 3x4. And then this negative 28 becomes positive 28. And this is all going to now equal 0. So let's collect some like terms here to simplify it. Notice how the 3x to the power 4 and the negative 3x to the power 4, those will just net out to 0. All right, we got 5x cubed and then negative 3x cubed, so that would be 2x cubed. We got negative 13x squared, and that is the only x squared around, so we'll just leave that as is. 7x plus 6x, that gives us 13x, and then this 28 is by itself as well. All right, so we took everything, brought it over to the left side, and we simplified all the like terms, and now we're left with 2x cubed minus 13x squared plus 13x plus 28 equals 0. So now what we have to do is we have to factor this polynomial on the left side. So the first thing we look for, can we take any constants out or any variables out? Well, no constants and then no variables. There's this constant at the end here that doesn't contain a x. So, unfortunately, we're going to have to use factor theorem. You can also check if this would work by grouping, but notice how from here we would take out an x squared, so we'd be left with 2x minus 13, but from here we could only take out a 1, and we'd be left with 13x plus 28, and those brackets wouldn't be the same. So we can't do it by grouping either. So we got to do factor theorem, so we got to plug in some numbers. So if we plug in f of 1, if we plug in 1 for all the x's, the 13s will cancel out. 2 plus 28, that would give us 30, so that's not going to work. If we plug in negative 1 for all the x's, you will get 0. And since an x value of negative 1 makes the whole polynomial equal to 0, we know by the factor theorem that x plus 1 is a factor. So now what we have to do is we have to divide this x plus 1 into this polynomial here, 2x cubed minus 13x squared plus 13x plus 28. And when you do that long division here, you end up getting 2x squared minus 15x plus 28 in the quotient, and you should get a remainder of 0 at the bottom. Okay, so basically what we've done is we took this polynomial here and we broke it down into the divisor, x plus 1, and the quotient, 2x squared minus 15x plus 28. Right, let me erase some stuff here just to give myself some more room. And now all that's left to do is to factor this quadratic. And when you factor this quadratic with decomposition, you would end up getting 2x minus 7, x minus 4. That's going to equal 0. So now, to find the solutions, all you have to do is take each of these brackets, make them equal to 0, and then solve for x. So for this one, we'll have x plus 1 equals 0. So that means x is equal to negative 1. That's one of the solutions. When does 2x minus 7 equal 0? Well, that happens when x is equal to 7 over 2. That's one of the solutions. And then when does x minus 4 equal 0? That happens when x is equal to 4. So those are your three solutions here. X equals negative 1, x equals 7 over 2, x equals 4. You can also check your answers by taking these x values, plugging them into the original polynomial equation you got and making sure that the left side equals the right side. And when you do so, you should get both sides equaling. I'm pretty sure these are the right answers, but you can double check yourselves.